goal in mind. All right, so we're going to talk about electron configurations and orbital diagrams. To start out with here, we got to quickly discuss the Aufbau Principle. Aufbau is not a scientist. Aufbau is a German word. Aufbau means building up. Okay. So the Aufbau Principle is the principle that electrons are going to position themselves in lower energy levels first when they encounter an atom without electrons, and they're going to fill up from there. Okay, so that means that there's going to be a distinct pattern to how these electrons fill in, and we're concerned with what that pattern is. Okay. I'm going to wind up showing you guys one way to remember the pattern today, and I'm going to tie in that pattern with another way to tell it next week. Can't do it tomorrow because tomorrow is Saturday. Okay. This isn't important to have in your notes, but this is actually a diagram of, bless you, this is a diagram of energy versus energy level versus orbital. Okay. So if you take a look over at the left-hand side over here, you'll see that energy is increasing as we go up on this graph. The energy levels, the N's, are labeled 1, 2, 3, and 4 over on the left side. Okay, so obviously a fourth energy level, a level 4N, is higher energy than a level 1N, N equals 1. Okay. Over on the right-hand side here, they've taken the pains to diagram out the differences in energy of specific orbitals. There's, at n equals 1, there's only one possible orbital, right? L equals 0, so we've only got a 1s. At n equals 2, we've got the possibility of n equals 0 or n equals 1. It turns out that n equals 0, the 2s, is lower in energy than the L equals 1, the 2p. Make sense? And this looks like the POGL, right? On the back of the POGL, when they broke out electron configurations, when you were drawing boxes, they showed that 1s was here. They showed that 2s was the next level up, and they showed that 2p was just a little bit higher in energy than the 2s. Does that look familiar? Okay. When we go up a little bit higher into the third energy level, we have three possibilities for the L. So we have 3s, we have 3p, and 3d. And you notice that it kind of makes sense. 3s has the least energy, 3d has the most. But if you start looking at the fourth energy level, where you get 4, something happens here, where the 4s actually has a little bit less energy than the 3d, and things start getting a little bit funky. Okay, so you don't have to draw this, but you do have to know that when you do the electron configurations, that it's not going to be as simple as saying 1s, 2s, 3s. It's not going to be as simple as saying 1s, 2s, 2p, 3s, 3p, 3d, because 4s actually has less energy than 3d, so you got to mention 4s before you mention 3d. Right, you guys want a way to remember that, right? Okay. Yeah, there's a fifth energy level, and a sixth, and a seventh, and things intermesh more when you get up there. So I want to show you guys an easier way to do this than to memorize a diagram. Okay. Can you write a triangle? This you want to write down. Okay, so this is something called the, some people call it the Aufbau tool, that's what I call it. Some people call it an Aufbau triangle or just the triangle. Basically, can you write S's all in a column? Oh no. We're not sure. Can you guys write S's all in a column? Yeah. 7 S's, right? Can you write P's all in a column next to it? Yeah, I think so. And D's all in a column next to it, and F's all in a column next to it. We're trying to make a nice triangle here. Or most of a piece of a triangle, actually. It looks like a triangle all the way up until you get the fourth, and then from the fifth, it's just kind of a rectangle underneath the triangle, right? Okay. Check this out. So we're going to draw diagonal lines, and this is going to help us figure out where the electrons go first. So first diagonal line is going to go down through that 1s. Okay, so the lowest energy is going to be 1s. Then we got to draw another diagonal line, and that's going to go through the 2s only. Now, if you look at the angle of the diagonal line, what's the next diagonal line going to go through? It's going to go through 2p and then 3s. 1s2, 2s2, 2p6, 3s2. Does that sound familiar so far? So if you follow these arrows, it's going to tell you the order in which these energy levels fill. Okay, there's 3p and 4s as the next arrow. So the first two arrows only get 1. The second two arrows get 2. The next arrow gets 3. Okay, so it's going to go through 3D, 4P, then 5S, then 4D, then 5P, then 6S, then 4F and 5D and 6P and 7S, 5F, 6D and 7P, oops, sorry. Apparently, I didn't bother putting in the rest of the arrows. 6F and 7D and then 7F would come next. Okay. I think you guys actually already have this in your notes, right? But I just want to talk about it really quickly. I know we've done electron configurations yesterday. The whole reason why the S's can only hold 2 electrons is because each orbital holds 2 electrons. S only has 1 orbital. P has 6 electrons because it has 3 orbitals. D has 10 because it holds 5. D holds 10 electrons because it has 5 orbitals. And F has 14 electrons because it holds 7. It has 7 orbitals, right? So Pauli's got a rule, and you're gonna be asked about this rule on the test. So this is an important one to put a star next to. Pauli has a rule that says that no 2 electrons in an atom can have the same 4 quantum numbers. So basically what he's saying there is that electrons have to spin differently from each other. So I cannot have 2 arrows in a box that point up. I think you guys noticed that on the Pauli yesterday. Actually, I know you guys noticed that on the Pauli yesterday. That also means I can't have 2 arrows that spin down or counterclockwise. So the only thing that I can have in an orbital diagram is to have electrons that have arrows that point up and down. This is the second rule. Hund's rule talks about how electrons are going to spread out if there's more than 1 orbital available. So if we have orbitals that have equal energy, now S's you don't have equal energy because there's not more than 1 orbital, but P's you have more than 1 orbital, right? You have 3 orbitals. D's you have 5 orbitals. In F's you have 7 orbitals. Hund's rule applies basically to the P's, the P's, the D's, and the F's. Okay. What Hund says is basically the same thing that you guys were using with the hotel analogy, is that electrons, given the opportunity, are going to want to be in different orbitals rather than being in the same orbital together. Just like random people wouldn't want to be put in the same hotel room together. Okay, so if I've got several electrons to put into an orbital, what Hund says is that first they're going to half fill their orbitals with parallel spins. We chose arbitrarily to say that they're going to spin clockwise. And by arbitrarily, I mean somebody decided that a long time ago, and we always use clockwise first. And then, according to Pauli, if I've got another electron, which direction does it have to go? It has to go counterclockwise, right? So we would draw it in as a down arrow. We want to draw an electron configuration for the element sodium. Okay. If I'm going to draw the electron configuration for sodium, what's the most important piece of information I need to know? How many electrons it has. It's got 11 electrons, so I'm going to write down an 11 over here just so that I remember that. Okay. I'm going to use that Aufbau triangle to know which orbitals to talk about first, second, third, and etc. According to the Aufbau triangle, which orbital do I use first? Not just S, but which S? 1s, right? Okay, so I go to 1s. How many electrons can be held in that 1s orbital? 2, which is where I write the superscript 2 in. Okay. Where do I go next? 2s is my next orbital. How many electrons can be held in the 2s? 2. So far I've used 4 electrons. What's next? 2p. How many electrons can I put in 2p? 6. Let's see, 6 plus 2 plus 2 is 10. So I've got one more electron to do. Where will it go? All right, according to the Aufbau tool, 3s. And how many electrons are in 3s? 1. I could write 2, but does sodium have 2? No, so that's why I stop at the 1. One of the rules is this. If I take the number of electrons that's in the superscript and I add those up, I should get the atomic number. I should get the number of electrons. Okay. So in order to do an orbital diagram, I have to have boxes that represent the orbitals. So I'm going to hand draw a 1s orbital. I'm going to hand draw a 2s orbital. I'm going to hand draw a 2p orbital. How many boxes will there be in a 2p orbital? There'll be 3. Okay. So there's my 2p. We tend to draw them horizontally just for the sake of space on the page. Okay. Technically speaking, the 2s is higher than the 1s. The 2p is slightly higher, and the 3s is even higher than both of those. But I tend to draw them horizontally rather than vertically. And you know what the difference is here, guys? Energy increases that way instead of up. Okay. So when I draw my 1s, now watch as I do this. According to the Aufbau principle, I have to fill in the lowest energy first. So I can't start my drawing over on the right-hand side with 3s because that's the highest energy. I have to start over on the left side here with 1s. Okay. So lowest energy first. I've got 2 electrons to fill in. According to Hund, it'll half fill before it starts going, but there's no such thing here, right? And Pauli says that they have to have opposite spins. So I'm going to draw 1 up, and I'm going to draw 1 down. Notice I don't draw the whole arrowhead? Yeah. Mostly because you're drawing a lot of arrows, and it's a heck of a lot easier to draw them like this with only 2 slashes rather than 3. Okay? There's no real tricky thing to it there. Okay. According to Hund, when I get to 2p, I've got to be careful because I have to draw my up arrows first. Okay. And then I can start doubling up. So I've got a half fill, and then I've got to use Pauli when I pair them up. So far, nothing interesting here, right? They've all filled. What's going to happen with 3s? Only half filled. And because somebody arbitrarily decided that they're spinning clockwise to start, we have to draw it up.